Hello. I'm Ingvar, and I'm alcoholic. Sorry, run me up. I'm performance engineer at Cloudflare. And just like Michael, I had to actually squeeze the talk that I was giving previously for about 30 minutes into 5 minutes. So I had to drop lots of slides. And what is left is actually just lots of code. And I will be speaking fast. So as Barry told, I hope I don't fry your brains today. So I'll talk about using ECMAScript 6 and higher features for nicer parallelism in JavaScript. Usually, if we drop away all the framework code and basically all the fancy stuff that we are doing, our code in JavaScript comes down to this. So we take something from our UI, pretend to do something very useful, actually just blocking the main thread for a while, and then just outputting the result. Now, the problem with this is that while we are doing our very useful calculations between reading and updating the UI, we just block the UI. All right. How do I? Another one. Great. OK, let's hope you can see. So the problem is we have some animations or other useful stuff running in the main thread. And in the very same thread, we run our JavaScript. Browser has to run there because we need synchronous access to our DOM and so on. So when we try to do anything in this UI, and while we are doing our extremely useful calculations, the UI is just getting blocked. All the animations stop, and we can't interact with the page, which is very bad for user, which is a source of most performance problems. Now let me. Yay. So the usual answer nowadays to solve this is obviously not to optimize our code, because no one wants to optimize it. It's just put it into another thread. And generally, this is a good idea, because now you have main thread, you have another one, and it looks cool. But some implementations, particularly in JavaScript, might really hurt when you try to work with them. So in JavaScript, in order to get this parallelism, we didn't have it at all for a while. But then we got web workers. Anyone familiar with web workers? Great. So web workers don't give you access to the DOM API. They just live in a separate thread. And in the latest Fast trends, they were designed not to share data with the main thread, but instead just to use message passing mechanism, where you just post messages to web worker, it does something, and sends data back. So in order to get our code running in a separate thread, we need to leave all the UI work in the main one, and then subscribe to messages from web worker to update the UI with the data that we retrieve, and post the inputs to web worker. Then on the web worker side, we subscribe to messages, get all our inputs, put our calculations there, and post the results back. In fact, in reality, it's even more complicated than that, because we need to track which exactly message are we responding to, and in order to know when to update the UI with our input. So we need to have some globally unique IDs. Let's say it's just increment, checks that it's exactly the ID that we requested, and on the web worker side, just send it back. So in the end, from a very simple code that we had initially, we end up with really complex client-server machine, where we need to just completely refactor our code into separate files and to send this data forth and back, subscribe to lots of events, and so on. And I mean, it's really fast. It kind of works. It doesn't block your UI. I probably should show a demo. Oh, man, it's complicated. Nope. So it's good. So now we can do it exactly the same, but our blocking stuff is just happening in separate thread. Multiplication is still waiting. Now it's calculated and so on. So it still works slowly, but it's in a separate thread. User can interact with your web page. Nothing is blocked. Perfect. The problem is that Nope. Is that while it's fast, like it flies, but it's really huge. It just doesn't feel right. What we really want to do is just take our initial code and tell the browser, OK, now please do that in parallel. I don't care like what you are doing behind the scenes. Just take my UI code, do that somewhere else. Don't block anything. So let's make some ECMAScript stuff. Earlier, it was not possible to do this. But with new ECMAScript features, by abusing them, we can actually achieve that effect. I'll just walk through some features that seem unrelated and later show how they mix. So one thing is promise APIs. I guess we are all familiar here with them because we work with service workers and so on. They allow you to just do something asynchronously, subscribe with .zen to on success on error callbacks, and just do stuff when you get the result. So what they allow you is to take is just to make some asynchronous stuff nice. And when you have lots of operations, like it's still the chain might be still complex to write. You still have this callback hell. It gets a little bit nicer with ES6 arrow functions. Like it just gets a little bit cleaner. But it's still not perfect because you have all these callbacks. You need to create some extra functions just to react to changes and to data that you're retrieving. And then in latest ECMAScript, we got async await, which is finally implemented in browser. In like Chrome, Firefox, Edge, all they have it natively now. So what it allows you is just to take your code and write it as if it's synchronous one, right? So how does it work? Like basically, when you write our expression await some promise and do something, it transforms your code to wait to the same promise API .zen, do something like wait for the result, and only then resume the execution with that result. Now, in order to be compatible with previous promises, like promise API was not always supported in browser natively, it had to support like all the Bluebird, any polyfills, like any promise libraries that existed before. So the decision was actually to rely on any Zenable object, so any objects that has Zen property with this resolve reject callback. Like if you pass it to await, it will wait for it, and that's it. So you literally can even do like something like console.hello, await for just literal object that has Zen property and resolves after some set timeout. It will wait for 3 seconds, and only then resumes the execution. Now, another thing that we got with ES6, I said like it's one feature. Another thing that we got with ES6 is proxy API. Anyone familiar with it? Yeah, so it's really rarely used, but why it's nice is it adds metaprogramming capabilities to JavaScript. So we can perform our own getter, setters, call operations, and so on any property, and dynamically generate properties that didn't really exist on the original object. So in this simple example, I'm just returning the name of the property, and you can see that when I'm chaining the proxy.a, for example, it just returns this name, and so on. So we can attach any handler that we want to any getter and setter dynamically. Now, as I said, await does not care where this Zen method is coming from. So what if in proxy, when we get property Zen, we just return a callback? But for anything else, we just create another proxy. In that case, we can. It looks like promise, and we can do things like proxy.a.zen, and it will just change the names. And for .zen, it will like log our result. And we can use it even with await. So when name is Zen, we return this callback that pretends to be a promise. And for anything else, we just store what we requested. Now, what if instead of just generate callbacks that resolves with the name itself, when we have .zen, we will just ask the main thread for something, for whatever we had in our chain of operations. In that case, like we can do proxy.a, and then we just store this operation that we requested A. We have proxy.a.b, we just store like we requested a.b. And only when it comes to await, we send this to the main thread and ask it to execute all these operations. So we can do things like await proxy.document get element by ID value. It will just create one huge object with like what we requested to do. sends this to the main thread like do something about it, and sends back the result. So after all, we can basically have our original, like what we really wanted. And if we add also destruction into the mix, like we can just destruction document out of it. So it really looks like exactly what we wanted. Just take our code, wrap it in parallel. The only thing that you need to remember is put a wait in front of every DOM API. But generally, you can just take your UI code, wrap it into parallel, and it will execute in the other thread with almost no extractions from you, no need for refactoring your code or something. And again, demo. So it's really doing exactly the same. So it's really doing exactly the same what previous code did, but like now just lots less code. If you want to see the resulting code, you can just come at any point. So yeah, thanks.